Applied parameters do not match the signature of the call target. And it's showing me right here what I need to supply, my first and my last name. So let me do this. I'll just do Jesse. And I keep hitting save. I'm so used to doing it. And there we go, right? So now we have the class. Yeah. The only thing though is that I'm not actually assigning them to anything. So it's not really going to do much. So there's two ways that we can do this. We can do something like this, where we do this dot first equals first. Oops, first. Okay. So what happened now is, what we're saying is that any one of these properties that come in, we can now assign them to one of our variables. But there's a catch to it. These variables are what we call scoped to the actual instance of the player. And what that means is that we can't reference them without saying that they belong to this. They belong to this object. So local variables within the scope of a class have to use the keyword this. How many people are like totally lost? I'm just like talking. It's okay. Anyone can like stop me and say, Jesse, what the F are you talking about? You're like really going off on a tangent. I figured I had to like add something in because I did this morning I did like really basic stuff.
And
this is like the most advanced stuff. All right, where did I lose everyone? Back like before classes?
So in order to call the class, you need to use first and last name. If somebody else
Yes.
kind of like waltzes in and tries to use it with a different argument, I guess it just won't work.
It won't work. I mean, technically you can put anything in there, right? But what I wanted to make sure that you did was, thanks. Right. I mean, the thing I'm trying to talk about now is just like higher structure stuff. But yes, in order for you to actually create this class, you need to supply the two properties, Jesse and Freeman, or whatever your string is for that.
How would you access those from outside the class? So you had to reference the class.
You have to have a reference in the class. So right. I want to sneeze, but I'm not there yet. Felt like I was going to. All right, here's how you reference it. So what I've done is when you create a new instance of something, right? You create a class, it automatically returns you a reference to that class. So if you look at what's actually getting outputted here, you see that it says return player. So here it's just creating a function called player and it's actually returning it. So that means that anything you create with a new command gives you back whatever gets created. So you have to store that into a variable. So here I'm storing the player. If I want to get the first name out of the player, I simply do myPlayer.firstName. And then I can get a reference to that variable.
What is the constructor, I guess, name for? Is that like just building?
This constructor, this is just a flag that says that that needs to be called. The first thing that happens when this gets created is that thing needs to be called. It'll automatically be called. So there's a lot of things you want to do when you initialize and you set up a class. Like in this case, we want to save the first name, right? And there's no way, this automatically means that whatever happens, whenever this is created, instantiated, we're automatically going to call this
When you say
function.
initialize something, it's like when you start your car, if you go through the same routine again.
As soon as you turn it on, right? As soon as you create a variable, you immediately gets, it gives you this opportunity to start doing stuff. So there's a lot you put in a constructor, like,
Like you start up a car and you put the key in, the first thing it has to do is to pass to the starter the energy to start up the engine.
Yeah, but
so that's a required thing that it has to do.
A car is kind of not a good example. I mean, think about.
I'm a car person, that's why.
Yeah, I'm trying to think of like a good analogy. I'm also trying to find like a good class that has a whole bunch of. This is a bad. I don't think I have any really high level stuff right now. Let me see. Yeah, start screen. This isn't going to be color coded. Nope, that was a bad one apparently. What's going on there? That was JavaScript, TypeScript. No, this isn't a good one either. Right. I mean, so like, okay, the example I was trying to pull up was like a splash screen. So before I even do anything, when I like load up a splash screen for a game, I have to load up the artwork. I have to do all this like preliminary stuff. I think, let's say you're going to launch a spaceship. There's a checklist of everything you need to do, right? Or you can even get to launching the rockets. They need to go through this whole procedure. That set of instructions of what you need to do before you're ready to even start the engine or rocket or whatever would be what goes in the constructor.
There's like an interface that you're talking about when you have to have this contract between things, or is it different?
The interface is different. I'll show an interface next. All right. Anyone really lost? I'm trying to figure out how to balance this between people who've never programmed and I'm just like jiving like the deep end of the program. Should I just keep continuing? You guys kind of sort of absorb it, and then one day, in a few years, maybe you'll understand it. Okay, so some of this stuff I was talking about earlier. Yeah, fine. We're gonna go real deep into this stuff, and we'll see what sticks. Okay, so I want to do this. Last name equals last. So this is what happens when I just do stuff off the cuff and I don't plan, and then you wind up with. I figured the other demo would take me a little bit longer. So even with the restarting the computer, it didn't take very long. Okay, so here what I've done in this player class is I've now created a constructor that will automatically assign the first and last. The last thing I want to do is score. So I will do this dot score equals score. I can't type it. Equals score. So this is kind of dangerous though, because what happens is that this score is actually set to null. So if this got created right now, what's going to happen is that score is going to be null, and I'm going to actually reset a value that's already set the default to 0 to score, to this value. So let me try to explain this to you. There's no value attached to this. By default, when I create this class, score automatically has 0. I always want score to be 0, right? What if right out the bat I add something to score? If it doesn't have a value, I'm going to get an NaN, right? Not a number. So one of the things that we can do to protect this is that you can give properties into functions a default value. So here I can hit equals 0, and that means that if I don't supply the value score, it's automatically going to be default to 0.
Oh, do you need then to define it up there before?
Well, you don't really need to define
It's
the 0
redundant.
there, but so you can actually remove this. But that's just something. So there's a lot of really cool things we can do with that. Now, the things that I want to show that are a little bit hopefully easier to wrap your head around is I'm going to create a new function. We'll call this get full name. So this function, what we're going to do is we have a player. We're giving him the first and the last name, but I want to actually create something that will give me back a clean version of the name with both of them concatenated together. So just as we added a function before, we're just adding this function onto the class. And that means at any point we can call this function and get a value back.
So that becomes a method of this class.
Yes. So now, yes. So jumping ahead of me. So now it no longer becomes a function. We call this a method. So there's a distinct difference between functions and methods, which is probably going to be lost on everyone because I still kind of use the words interchangeably. But a function is something that just exists in the scope and it contains instructions. It's a function, it's scoped globally, it is whatever.
It just does what it says it
Yeah.
does.
Once it's applied to an object though, or it's part of a class, it's called a method. Because now it's a method of that class. It belongs to that class. And the key differentiator is that a function outside of a class, its scope meaning where it can talk to things in the programming world, exist on the same level. It means that everything outside of this class or this function, it all talks globally of the root. In this function, though, in this method now, inside of here, it can only talk to stuff inside of this class. It knows nothing about any of these variables outside of it. It has no clue. And so methods are scoped specifically to the object that they're attached to. That's why in this case, we're using this keyword, because we're saying we need this object's or this class's score. We can't get score from anywhere else but from within itself.
What would happen if you didn't put this?
It just gives you an error. It says, no, I don't know where, well, score will actually work because it's being passed in by there. That's a
Oh, that's right, yeah.
But, and that's when you get into like really bad problems.
This is probably a dumb question.
Here, this should give you an error. This is like, there's nothing, it hasn't been declared.
Right.
Here, what's your question?
Are methods like,
Okay.
let me see what.
Glad I was able to help.
Are methods like a way in which the object's achieving its like purpose or function?
Yeah, it's just for adding additional logic to something that's reusable, right? So methods do all kinds of things. Like everything really is a method, right? You would have a class that represents your player. So if I want to make the player move, I would have a method for that. In this case, I'm going to make a method for get full name. I would have a scoreboard. I would create a new class that was the scoreboard, and that class's only goal would be to hold scores. Add score, remove score, get high score. Those would all be methods on top of that class.
If you have an object spaceship, you can get fuel, you can get all the other.
Right. So here we're going to have this. So now the constructor automatically returns a reference to itself. I create a player, I get a player back, right? Methods need to have a type that returns to, just like everything else in typing. So here, I'm going to actually give this a string as a type. And you'll see I'm getting an error because I'm not returning anything. So right away, I know that I always want to get a string back, right? The name is a string. I want to make sure that I'm returning a string. So here, I'm going to return first. Oh, that didn't work out very well. First name plus space plus, I see why, and I'm already screwing it up. That's in JavaScript in my head. This dot first name, this dot last name.
You already kind of know here that there's some error because.
Yeah, so well, and this is kind of why, yeah, the compiler is awesome, is the compiler's telling me, hey, you got a red line, like, I don't know what you're doing, and it makes you think back of what.
Can you do this inside Visual Studio?
Yeah, this all works in Visual Studio. This is just for them, you to play around with the language online, but usually you do this all in Visual Studio. So, okay, so here we're going to get the full name, and all that's going to do is it's going to take this variable, which is this first name, add a space into it, and this last name, and then return it. So I did that function before, earlier this morning, but in this case, now it's attached to player. So if I did this player dot get full name, oh, also you'll see right here, you'll see when I'm doing the code completion, it also tells you like, oh, it's going to give you back a string. So as you're typing, you know, okay, don't assign this to a number variable, right? All right, so I'll run it again. Not like it shows anything pretty, but then I go to my console, and I did something stupid. What I did was I didn't actually make it a function. I just called a reference to it. I'm not going to get into that. That just will really make everyone cry. It's really hard because it's like functions can be assigned to variables so that you can call them, and it's like, yeah. Programming's hard, kids. I wish I could make it easier. All right, so now I'm going to return Jesse Freeman as my string. All right, so we'll do a toss-up. Who wants to learn about extending classes or interfaces?
Both.
Well, which one first? Do we want to talk about
Classes. We're starting with classes here.
Okay, so we'll continue with classes. So, all right. The pinnacle of object-oriented language is, of course now it's going to escape my head. Polymorphism. I'm going to use some very big words. All right, polymorphism is the ability for you to actually create classes and extend off them and build on top of them. So let's say, what's a good example? Let's say we want to make a ninja, right? We all like ninjas. Who doesn't like ninjas? We're going to do a class. Oops. Ninja. Man, it's that time of the day, right? So here we go. I created a class called Ninja. And, well, ninjas have first names, and ninjas have last names, and ninjas have scores. Right? So what do? Copy and paste all that and put it in there? That sounds really stupid. Remember, the key to being a good programmer is being incredibly lazy. Don't, if you write the same thing over and over again somewhere, you've done it wrong. You've done it 100% wrong. Polymorphism revolves around the simple fact that I can do something like this. Extends, click. And now what this means is that whenever I create a new ninja, it's automatically going to get all of this stuff for free.
So you can actually use get full name method inside
Yep.
Ninja.
Yes. Ninja gets created and it'll have a get full name method automatically. Makes sense, right? Now you're probably thinking like, why would I ever do that? All right. Well, let's say Ninja, we want to say that, you know, when we get the full name back. So here we go. We're going to do something called overriding a method. What that means is that the parent class had a method that we liked, but we needed to add additional logic onto it. So in this case, when we get full name, it's still going to be a string. And we want to return the word ninja, but we want to add something else. We also want to get the full name back, right? And again, who wants to just write this full name and this last name? Is that what we should write there? Anyone? No, because we're lazy programmers. So what we do is this thing called this.parent. Oh, is this going to work? Oh, how do you extend in this language? No, that's not it. Hold on, I have to look it up. My brain just like crapped out. What? Hold on. Where do I have extends? I could have sworn that it's, all right. This is the key to being a good programmer.
Libraries.
Override method in TypeScript. You laugh, but I'm telling you, this is all I do. Because I can't remember, because I have like so many things in my head.
That's
So-
good to hear because
No, I mean, no one remembers this stuff. It's something like this parent dot. Oh, what is
is
this?
there result?
This is the wrong language. Hold on.
Maybe super.
No, super would be in the constructor.
Yeah.
Super, is it the super? No, that can't be it. That'd be too easy.
That's in Java.
No, but it'll tell me, hold on, maybe the compiler does it. Property of super doesn't exist. This dot, I thought it was this dot parent. That's my parent. Hold on, I have this. Well, this is the best part, right? So we're gonna go look. We're gonna look it up because I can't remember. How to override also helps when I can spell. All right, let's see if this works. Function overriding.
Okay. I saw super. That's good.
Yeah, no, I saw super too, but that wasn't. Super was just in the constructor.
I think you just override it by just rewriting the code. You just don't do anything. You don't do anything else.
No. Well, we'll try it out. Hold on. There's two parts of programming: searching and experimenting.
Yeah, I just searched. This is what I found.
No, da. Yeah, and another reason why I don't do live coding. is I can always forget something. This is I'll look it up in one minute.
You want to get method get full name? You check it full name.
Yeah, it didn't like that. It didn't like that at all. Or did I not put the, yeah, I forgot to make it a method.
What is these base?
Yeah, out of stack. All right. No, it's not bait. It's so simple. As soon as I see it, I'm gonna like kick myself in the butt for.
Sure, do it like this.
Hold on. See, I mean, this is it. At the end of the day, like, I literally have to just go back through and look it up. But for some reason, my brain just doesn't want to work. So let me see. I'm in TypeScript. Where is a good project? Archive. I want lib graphics. This, no, it's the JavaScript. Sorry, hold on a second. I have to find the TypeScript one. Graphics. Oh, one of these bad boys has it. No, it's constructor. I'm looking for somewhere where I override the method. I can't believe I'm like blanking out on this right now.
Okay.
Search for parent.
What?
Search. Do a search on parent in here.
No, I don't know if this even extends it. Where do I extend it?
Yeah, that's so super.
It's not super either. Spreadsheet animation, constructor. Oh man, is this going to be my downfall today? Is this one stupid thing that should take like 2 seconds to show? Ah, son of a. It's super.method. Wow. That's why I couldn't remember. I'm like, what's going on in my head? So yes, you're right.
It's the reversible.
Yeah, it was a reverse. It wasn't parent. There's another language where it was like parent. I've actually.
Yeah, it's 3 that's that.
AS3, is that what it was I was channeling? Great.
Yeah.
Okay. So back in the real world, it
Super
is
dot get full name.
super.get full name.
On
All
the
right.
wall.
It's time for us to stop and get a drink, right?
Yeah.
I said that like, what, like 10 a.m.? So here we go. Now when we return it, it says Ninja Foobar. Okay. To recap, after I totally screwed that all up. The point of this really is that you can take existing functionality and you can add on to it, right? And it doesn't need to be returned in the same line. I could literally have super.getFullName go to a variable, do a whole bunch of stuff to that variable, then return it later, right? So once you get the whole concept of creating a variable, assigning values to it, creating methods that return variables, and doing this cycle, it kind of all makes sense. All right, so the next thing that I want to do, the other part of polymorphism and object-oriented programming is the notion of, we talked about typing. There's this really important thing, actually I kind of screwed up down here, I didn't even do it here, but let's say right here, wherever I create the player, I need to type it to player, and Ninja, I need to type it to Ninja. But sometimes there are cases where we want to create a class that has the same signature as this class, but doesn't actually extend it. A good example of this would be a monster, right? There's no point in a monster having score, and the monster really isn't the player. So one of the things that we can do is we'll create a class here called class monster. And what we want to be able to do is we want to be able to at least do var monster is new monster, and we're going to give it a name, you know, bad monster. well, we'll give it, yeah, we'll do this, it's fine, whatever, just for the example. And console.log, I want to be able to get monster dot get full name. So here's a very unique case where I told you not to copy over the same code. But there are certain instances where we're just going to have to do it anyways. But one thing that we can do is that the key to polymorphism in object-oriented languages is that you never type to a specific instance, you type to an interface. And what does that mean? So an interface is kind of like a class, but it doesn't have any logic in it. So interface, and we're going to call this I have a name. So interfaces, depending on who you talk to and what language you're in, will generally start with this thing called I, just to let you know that it's an interface. Some languages treat interfaces as first-class citizens, so in Java, they generally don't put I in front of it, they just treat it as a class. It's really weird, but most of the stuff I've been doing, I've done I. And what we can do in interfaces is we say anything that belongs to this interface has to have this method get full name, and it has to return a string. So what happens is that we now have this special thing that if we want to make sure that something, we want to call get full name, we don't actually have to type at the player or monster. I'll show you how a monster will play this in the middle in a minute. We can actually create this as a type now. So if I go down here and I look at my monster and I change it to I have full name. Is that what I called it? Yeah, I have a name. You'll see that that went away, right? So right now what happens is now, instead of me typing this to a concrete class, this variable is not a player, this variable is not a monster, it just belongs to this interface, I have a name. I'm literally guaranteeing that in the next line, whenever I call this method get full name, that any class that implements this interface will have to have that function. So the way that we do that is we do implement implements I have code completion. So I'm going to stop typing. I have name. So before I kind of showed you extend, right? And extend took functionality from another class. What implement means is that it just agrees that, all right, I agree that I'm going to have whatever methods are part of this interface. So right now I don't have those methods, so it's giving me an error.
But that method has nothing to do with the get full name that we have inside the class.
Nope, has nothing to do with it, right? So in this one, I'm going to do a different thing. Get full name string, and here I'll just return monster. But what I actually wanted to do is just to make it even more confusing. Use constructor first, last. This is the part where I stop typing. So I start adding type, stop adding type to things because I'm lazy. But here, we'll do first, last, string, and this will go. A neat trick, by the way, is I can actually do something like this. I know, I'm just gonna see if I can break everyone here today.
This is gonna bring in.
Yeah, what this is gonna do is that before, remember how I declared first and last name at the top of the class as variables? Well, this is actually just telling you this is a shortcut. It's saying, well, we'll just make those variables for you. So you don't actually have to add them.
Basically, that allows you not to having to go up
Yeah,
inside declare anything.
Right now I don't have to
It's
go back and
already
redeclare it, right? So I've simplified my whole constructor. So now down here, I'll just make that 2 strings. So now what happens is that my monster is guaranteed to have get full name. I'm going to do first this dot first, this dot last. I just hit save again. I'll do that. Okay. So what happens is that now, I still had to rewrite some of that code, right? But what I've done is something even more important, is that over time, you're going to build all kinds of different monsters, right? Or all kinds of different anything. But there are times where you want to just make sure that no matter what the object is, no matter what class it comes from, or where it extends, or whatever its hierarchy is that you just want to make sure that you can just call this method on it. And for that, you just type it to that interface. And that means that whenever something of that type or implements that interface, you always make sure 100% that you have that method to call. So hard to explain, because it takes so long to kind of comprehend it, but as you start getting into typing, you'll learn a little bit more.
So what would be the difference between this interface and the method we did before, I mean, and the class that we generated before?
Well, what happens is that technically,
Because we could do it either way.
this should
also create
have,
another
so
class.
here's where it comes down to, right? So monster doesn't extend player, right? But monster and player have the same method. So if I was to actually go down here and say player, that should break.
Yeah.
Well,
Yeah, it
the
should.
compiler is acting stupid. That shouldn't let me do it. It just is testing that I actually have that method, but that's not right. The player actually needs to implement that method. Implements. I have. Oh, hit save again. Okay. Technically, what that means is that right now I can swap this out. I can make that a player or I can make that a monster. It doesn't really matter. All I know at the end of the day is that I can actually just call that method.
But you have to have the method separately in both the interface
Yes.
and the class,
Yes.
which they had nothing to do
They
with
have
each
nothing to
other.
do
You
with
have
each
to. That's a case where you cannot be lazy. You have to have both of them.
You have to have both of them, and the compiler won't let you do that. The question?
Yeah, so I guess really what I'm picking up is once you call something, like once you build something elsewhere, you can just infinitely call it, kind of, as long as you use the same syntax or practices.
This is a protection, right? The protection is that you can't call a method that doesn't exist on an object. It throws an error. So what you're doing is you're protecting yourself. It's like a blueprint, basically. You're making sure that nothing can be built without these basic building blocks. This class cannot exist without these methods. But what's different is that, you know, think of it like this, right? Buildings is a subcategory, right? There are all kinds of different buildings. There are houses, there's apartments, there's factories, right? But they all have common things. They let people in, they have roofs, they have walls, right? They have windows, they have all these things that define them, right? You may say, let's say we're building SimCity, okay? Let's take this actually back to gaming where I should have done this from the beginning, right? So we're building SimCity, and we have a plot of land. And that plot of land needs something. Now, you could put a house there, you could put a factory, you could put a power plant, right? But all those things are buildings. And at the end of the day, we just need to make sure that whatever goes in that spot, we wouldn't want to put a power line where a building goes, right? And buildings all have these common traits that they're going to need in SimCity, right? What is their cost? What is this or that? So each of the buildings would implement an interface, and the interface would say, I building. And it would have whatever properties belong to a building. I cost this much, I take up this much space, I'm allowed in this zone, or whatever. And then the plot of land would say, if I'm going to do something like add building to plot A, plot A would say, well, I want to make sure I'm not looking for just factories, right? I can have, there's all these different types of things, I'm just looking for buildings. And as long as I have a building, I'll accept it. Does that make sense?
It's like it's coming, it's clicking. Yeah,
It's-
slowly, but yeah.
It's
I
complicated.
generally get what you're trying to say.
Because at the end of the day, it's like as you build your game, you can't anticipate what else you'll need down the road. And when you're in a typed language, you have to really pay attention to being able to expand and build on top of it. So interfaces allow you a way to just say, all right, well down the road, I know I'm going to need something that does this, but it may not come from this class or that class, maybe its own type of class, but it still does the same functionality somehow. So you know you want to type it to something that's not a concrete class.
You're creating a common denominator for the interface that can be then expanded.
Yes.
Or in that case, implemented.
So, I feel like I've gone over a lot of stuff. Who wants to take a mental break? Who wants to stop? Or who wants to keep going? Because I got 15 years of this in my hair. This is like the basic stuff. I mean, when you get to a higher, then you kind of see why I started with JavaScript, because JavaScript's a lot easier, but you don't have to deal with all this stuff.
It's more scripting.
Yeah, it's just,
It's not really object oriented.
but this stuff is like higher level language. And it's close, because it works very similar to the way that, you know, JavaScript will work, but it just adds a whole other level of complexity.
Why is it, what is the warning over there?
Are these warnings? I don't know. No clue. All right. What else are interesting about this language? So I've talked about inheritance, I've talked about interface, I've talked about classes. Aha. Okay. Module. So you have a whole bunch of classes, right? Now what happens if you're building your game and you have a house and then you get this great library that exists out there and that library also has a house class? The two of them conflict, right? So the way we avoid that conflict is we create something called the module. And in other languages, these are called packages. And what it does is it scopes that class to a specific object. So to kind of back up a minute, what it means is that you're able to actually put classes inside of a folder, basically, if you think about it mentally, a folder or group. And if that group is a unique name, you don't have to worry about conflicts in another library.
It's like a wrapper.
It's a wrapper for it. So, you know, in some languages, it's actually literally just the folders in your computer, and those folders are
Is that the one that we will use with dot notation?
You'll dot and stuff like
dot,
that.
whatever.
In JavaScript, it doesn't really matter. But in this case, since I'm doing it all in one file, so here I have module stuff, and I'm going to make a class called computer. That's stuff, right? And we'll just leave it at that. Did it again. Okay. So if I want to create a new computer, var comp equals new computer, it's not going to work.
Type computer comp.
Because what's happening is that it's looking for computer as a class, but it doesn't exist anywhere. It exists in the scope of this module. So in order to do that, I need to do stuff dot computer. But here's the even better part, right? So right off the bat, module is scoped to itself. What it means is that this class only exists in this little world. It's called an inner class in programming. Nothing else can ever see it. It's protected. The way we get around it is that in TypeScript, we can do this thing here called export. And now this cleared it up. And what export means is that it just says that this is a public class that anything can use. And the way we get access to it is by just doing stuff.computer. So we've looked at the module stuff, and we're now looking at the class computer.
So once it's exported, it's like available publicly from outside.
Mm-hmm.
Do you have to type comp something? Like var comp has a type?
Yeah, I can type it too.
What type would it be?
It would just be stuff,
Oh, okay. So it takes the
computer.
the name of the module.
Yeah. So this is a good way for me to package up lots of different classes. So we usually package up stuff based on their kind of what they do, right? So geometry stuff, math would be in a geom package. Sprites, text would all be in a display
Physics.
package. Yeah. So like you use package these things up. Core is a common one, although I think we always like fight over core. You also fight a lot with other developers over what these things should be called. But you know, core kind of just holds in whatever else you don't know. You just kind of throw everything in core. But anyways, that's kind of another way. I think the last thing I'll do, and then I'll stop talking, is I'll talk about the difference between public and private. So before we had talked about these properties are public. What it means is that anything can actually access them. So when I created a new player, I went to first name. There are lots of times when you want to protect things. Just like you're protecting that class in the module, we want to make sure that other classes can't talk to properties because we don't want to pollute a variable. So in high-level programming and in enterprise software, nothing should be public. Everything should be accessible by methods. So what it means is that no routine could modify an object without doing something very specific to it. You can't just get a name of a property and change it. You want to go through a method to do that. One of the ways that we can do that is we can denote that a property is private or a property is public. And private is basically, imagine you make something that's read-only, right? If you're building an enterprise app and it's for a bank and it's getting data, it should never be able to modify that data. All the data should be private, right? But there are times when you do need to change it. So one of the things that we can do is, since this is private, if I went down here, you see how I'm now using get full name? I can't access the name of that variable directly because it's private. But I'm using a method called get full name to give me access to that. So I protected this class from being corrupted by another class by simply using something to access that data.
How could it be corrected? I mean, how could it be corrupted though from, because you still have it as only as a variable that says get full name, you have a method that receives first and last name.
But
You don't
let's
have a
say-
set full name, right?
But let's say you did something like this. Let's say you did,
Or you reassign a value to the variable.
what if you reassign, what if you did something like this? console.log.myPlayer.age plus plus.
Right.
I mean, you can't really do this, but let's just say you had age and you started incrementing age.
So if
What
it's
can happen
private, it
is
will
that
never happen.
if it's private, it won't happen.
Okay.
What happens is that you're in a loop and you're accidentally actually modifying the class. Then when you get out of that loop and you get to another function, it goes look at the age and that whole number is completely off.
Right.
When you return the number from a method, it gives you a clean copy of that value. So this is like much higher level stuff. But
So private is going to be a very, very strong protection
Yeah.
on that one.
So I think that's enough for today. Does anyone have any questions?
We should have recorded
Nice
this
steer
because of
there.
that.
I know. I'll write all this stuff down. I mean, it's all well. I mean, it's like kind of well documented. But the problem is, like, even if you read through it,
Yeah.
it's really about context. Like, I think what I need to do is, if I continue to teach these kind of programming things, is find better context to it. It's hard. It's like I built a simple app with it, but I think building a simple app is also so complex, you know, depending on the level of programming. So I'll probably just do the same talk again, and then you'll be like, I remember him saying that. Or I'll just test you all. There's nothing that says learning.
Oh, that's
like a
why you
written
can
test.
actually record it once, replay many.
Right. But I mean, like it takes a long time to do this, but this is kind of where you go from JavaScript as you go into higher level languages. And this is the stuff that you'll start seeing in, like, if you're doing Unity and you want to do C#. C# is a strongly typed language. It's a lot more complex than this. Same principles, but right, you know, there's, you know, this stuff is kind of important. Java, you want to do Android development or server stuff. I don't know why you want to do server stuff, but Java does this. So, you know, it's good stuff to kind of see.
So the same paradigm will apply also to the other languages.
Mm-hmm. Oh, yeah.
And like the same thing will apply to AS3, having interfaces on and so
Yes.
forth.
So from this, you'd be able to move from ActionScript, JavaScript, to Java, to C# relatively easy.
With a lot of emphasis on relatively.
Well, right. It's super easy. I just couldn't remember, what was it? It
The
was
super dot.
super dot method. That's the problem. Is like everyone has a little tweak difference, dramatic.
The lack of standardization, because as soon as I saw that when you type, you cannot use the uppercase.
Yeah.
Which actually would be like, why not? It used to be uppercase, at least in history, it's all has uppercase, right? So
Right.
you had to, why is it lowercase? Oh, don't ask, just do it.
Well, yeah, then you'll see like, right, if you go to like C# or .NET, all the methods are capital camel case. So they start with all capitals, but if you've been doing lowercase camel case for a long time, it's like, you know. there's
Capital,
like-
oh, you mean the first one is it's capital?
Yeah, so like the method, so if this was,
That's like the I interface, I said? Like
it would be like this. Capital G.
Oh, come on.
So
Really?
then it looks like super ugly.
So usually it starts with lowercase and then.
Yeah, but not in .NET. Everything is like capital.
Why
When you
did
say
they
strongly
standardize
typed,
this
What
stuff?
do you mean when you say that? What,
This is a strongly typed language. It means you have to explicitly describe the type for each variable. Is that, that's like the whole thing, right? Versus JavaScript we did this morning where it was loosely typed. It didn't matter. The compiler kind of figured out whether it was doing a
Yeah,
type
it
or
could be a
not.
number, it could be a string.
Yeah.
And this one you can omit the time.
Yeah, this one
So,
you can kind of ignore. it.
Kind of, it's not very strongly typed, it kind
Right.
of lacks time.
Yeah. But the thing is that if you were doing this stuff in JavaScript, like you'll start seeing it's outputting all this crazy stuff here. But like just to do the ability to extend, this is the code that you need to write
Holy.
in JavaScript. And here's where it gets like super weird. How do you even explain this? So prototype is a way of altering anything in JavaScript. So you can actually rewrite. So remember earlier in the morning I showed you how I rewrote console so that I can output it to the window. This is like going into the core of an object inside of JavaScript and rewriting it to understand what the command extend is. So it's like altering the language on the fly. And then to do a class, it's here you see it's calling this underscore extends and it's getting this and super and it's writing all this nasty stuff. So before, in JavaScript, you actually just wrote this stuff out by hand. It's really ugly. It's an ugly language. This makes it a lot cleaner. Right. That's all I got.
Can I
Yes.
ask one? Well, what's the difference between interface and class?
An interface in class? Well, an interface doesn't have any code logic. It just has the names of the public
Oh,
methods.
okay.
And the class is the one that has all the logic.
Okay.
Well, thanks for sitting through this all day. Then you, like, you feel like, yes, I got it. It makes no sense. And you walk home, you're like, I don't know any of this. What did he say? Var variable is a container. It'll stick. I mean, you just got to do it over and over. That's like really the key.